Ahmed already introduced me, and this is my team. Many of them are already here today, and my talk includes their work. So if you have extra questions, feel free to go to them and talk to them about their work. So following up on what my colleagues were describing this morning, AI codes for us. It has come a long way from simple single token prediction to full-line code completion, and also nowadays, more recently, on agents that code, test, and refactor code for us. So reports show that there are millions of developers around the globe using these AI companions, such as Copilot, GitHub, and also like JetBrains AI Assistant. And in some organization, nearly half of the code is AI generated, which is like mind-blowing. So we love them, right? But do we truly trust these models and these toolings? For that, we can look at some of the stats that are available. For example, GitHub reported that developers code 55% faster using the GitHub Copilot. Google reported about 6% reduction in the coding iteration time, which is for a big tech company, and the scale that they have is really huge. And there are more success stories from JetBrains, Amazon, Morgan Stanley. Like they even reported 98% of their clients use AI assistants. So these stories, these success stories are out there, and they are everywhere. But these tools are powerful. However, there is fragile evidence and very scattered, fragmented reports on evaluating these models. Sometimes they can be biased, and sometimes they can be overlooking important aspects, for example, such as what are the hidden risks? What are the biases? Does these models generalize to our cases in our specific company, for example? So we do need rigorous evaluations to have a better understanding of the performance of these models and these agents across different disciplines to avoid coding blind. And to do that, we need independent, real-world evaluation of these models. This is what we do in our lab, and today I'm going to talk about a little bit about different types of the work that we do in this regard. So first, online evaluation. This is one of the earliest work we did in this regard. We developed an independent assessment of open-weight language models by Meta and Microsoft inside the code editor itself, like compared to the offline setups that you just get data from the internet, like for example GitHub, and run your models on it. We actually wanted to evaluate these models inside the IDEs. So for this case, we got JetBrains and VS Code. We had 3 models, Encoder, Unix Coder, and CodeGPT. And we targeted the task of line completion, which was suitable for the size of these models, because these are like around 1 billion and less. This is not like Copilot, which is billions of parameters. We supported multilinguality, like about 20 programming languages. And when we distributed this plugin, we had around like 2,700 downloads and 1,500 users, which was really nice in an academic setting. And we started collecting the telemetry data from these users using these open-weight models inside their own IDEs and for their own daily tasks. This is a screenshot of our repository with the QR code. You can access it. And also, this is how we serve the completions in the format of line completion. So we collected telemetry data. And what kind of telemetry data was this? It was trigger points, the trigger type. Was it automatically triggered, or was it manually triggered? The completions by all of the 3 models suggested for the users, whether they had accepted it or not, and what did they wrote after 30 seconds, which we use this as the ground truth for the code completions. To also answer more interesting questions about like the failure cases, we needed the context of the code, but this, you can imagine, is kind of private. So we asked for opt-in users that whether they would give us their consent to collect their context of code so we can study it. And out of the 1,500 users that we have, 168 gave us their consent to study their code context. We ran this for over 15 months, and we collected about 2 million data points initially, but then we started filtering the data, and it rounded up to like 600,000 data points for 12 programming languages that we could study. We had 5 research questions in the report, but I'm going to just go over 2 of them. The first one is the acceptance rate over these models inside the IDE, and you can see the performance per model here. The first thing that pops up is the really low acceptance rate, which at the time, if we were comparing it with offline evaluations, you would be thinking that these models they are the best out there and like 60% blue score. But looking at the acceptance inside the IDE, you could see that the users and developers actually didn't accept too many of them. So there were really a lot of room for improvement. The other observation here is the difference between programming languages, and you can imagine the mainstream languages, they perform better because like they are more prevalent in the training set, and users, like the models were more accomplished on them. And the last one is the difference between the models themselves. Here, encoder was a clear, better choice, and we associated that with the size of the model and the fact that it was a bidirectional model, meaning that the other 2 models, UnixCoder and CodeGPT, only looked at the left context, while encoder left at both contexts. And that alludes to the fact that developers don't just write left to right, but they edit code, they go back, and the model needs to attend to both, like the whole context there to perform well. My favorite research question was actually on what happens when these models fail, and with the help of our students, we actually studied a large number of samples in the case of the failures, and we were able to build a taxonomy what's going on wrong. So about 66% of the cases, we were able to identify that it was something about the model, that the model was falling short of generating the correct prediction. It could be like about just repeating, rambling. This was like one of the cases that the language models suffered from, or they had like faulty syntax, wrong parameter count, and wrong semantics. But there were also 24% cases of it was related to the application of these models inside the IDE, meaning that the developer invoked the model where there was not sufficient context for the model to predict anything. So you can imagine, if it's like at the very beginning, there isn't anything in there, so the model is just guessing. There were cases that no invocation was needed, but the editor invoked it, and it was just simply ignored by the developer. There were cases of mid-token invocation, which is now resolved by like companies like JetBrains, Meta. They have done token healing to revive this. And finally, we also identified if there were like typos, mistakes, etc. in the context of the code, the model often became confused and made wrong generations. So the goal here is to say that it's also about the application, not the model itself, but also the application. And finally, 10% of the cases, it was user preferences. For example, it was a correct answer, but it wasn't accepted by the user. Maybe they wanted it in another style, or they wanted another API which did the same thing, but they preferred it. So we can see, looking at all of this, we can see that there are many things that can go wrong, and in practice, we need to go beyond looking at just the model, but also its application and the preferences of the users of your system. Okay, here I included an offline example for evaluation. This was recent work one of my master's students did with ASML. Their meteorology department wanted to see whether the off-the-shelf language models work for their cases, especially on their own data. And they have these modules called garages, which is very specific to their department. And we tried different model families, Qwen, Gemma, and DeepSeek, both the generic versions and the code-specific versions with different methods. Like we didn't fine-tune these models, we just wanted to see if you just take these models and apply it to a company data, how does that work out for them? And we tried different prompting techniques, 0 shot, one shot, and like few shot, and lastly, chain of thought. And the main takeaway from this study was that we could get high metrics like Rouge, but something more functional, such as pass.k, still struggled. And even build.k, which we introduced in this work, they were still really low. The second observation here was that it really depends on the model family, like whether their generic version and their code version perform differently. So for some of the models, we could see a really different performance between them, and for some, they didn't differ. And lastly, the model size, because we tried out different sizes, 3 billion, 7 billion, 15 billion, 32 billion, and what we observed was that, of course, with the model size, the performance grew, but it was with a diminishing effect as we go on with the size. So these helped the metrology department in SML to make a choice about what models they want to use, how they want to use it, with which prompt techniques. Next, I would like to talk about the benchmarking landscape for AI for SE. Here we did a review on all of the benchmarking out for AI for SE, and we identified, my students actually, they identified 273 benchmarks out there. You can see there is a really growing trend, and it's every day you hear about a new benchmark. You probably have heard about human eval, MBPP. These are like the stars of the benchmarking landscape. And what we observed here is that the field is very fragmented. And many of these benchmarks are poorly maintained and have weaknesses. So I'm going to talk about a little about what are these shortcomings in the benchmarking. Let's just start with a funny example here. So this is actually a sample of the human eval, the famous human eval that everybody uses for evaluating their large language models. And Dai actually also introduced it, that it has function signatures, and you write the function, and it has a few tests to try it out. Here we want to see what's the median of this list. I think you can guess that the median should be 8. If we sort it, then it should be 8. But the system, the benchmark says it's 15. And if you try it on ChatGPT, at least the version that we tried it in December 23, it gave the exact same mistaken result. So you can see that it not only is predicting wrong, but it also is just copying what it saw in the benchmark, kind of have memorized it, and then another system is showing the same wrong answer. So aside from the mistake, you can see that's the data contamination. And don't worry, this is now fixed. But you can extrapolate and see that these kind of mistakes and memorizing these mistakes and propagating those mistakes from benchmarks to the actual toolings that we have access to is a real problem. And it also shows that these benchmarks need real and careful reviews to be useful for us. Another issue is the saturation of these benchmarks. Like here you can see that the models are 100% performing on human eval, something like human eval. The same goes for MBPP, so saturation has already happened. We need better or stronger benchmarks in the field. Another angle we can look at is the kind of programming languages used in this benchmarking. And Python and Java are dominating the field of benchmarking. Most of the benchmarks out there are covering these languages, while they are neglecting or ignoring the other languages, which are also many developers or companies use them. The same goes for natural language. Without almost everything is on English, and you can see that there are very few benchmarks for other languages. Another aspect is the evaluation metrics in these benchmarks. Most of them focus on exact match, similarity-based metrics such as BLEU, Rouge, etc. But we need to also capture semantic. So CodeBird score was which uses token embeddings, is used in some of them, beyond that, we just don't need to repeat the same exact token, but we also need code to be functional. So many have started using PassAtK, which is a really good step. But finally, it's not just about accuracy. These benchmarks need to go beyond accuracy and look at other aspects such as robustness, harmfulness, creativity, and many more angles that we can be evaluating our models on. And lastly, looking at the task diversity, many of these benchmarks are focused on a few main categories, which are generation, summarization, and repair. But there are many other tasks that we need better benchmarks for. So what are our efforts in our lab for AI for C benchmarking? First of all, we developed a tool for visualizing and searching the benchmarks out there. It's like it covers everything, it's up to date, and you can just search for whatever you need in your company, in your university. And we have also tested out this with 22 participants. Here is a screenshot of the Bench Scout. In the text box, if you choose or write anything about the language or task that you're looking for, you can easily see what type of benchmarks are out there that you can use, and you can also see all the literature around it, like the other studies that use this benchmark. We also propose a bench frame, which is a framework for repairing and refining the existing benchmarks. Why do we want to refine them, not just build a new one? Because many of these benchmarks, when they become popular, they tend to stick there. For example, there are various versions of human eval translated automatically to other languages, etc. There are various versions of SUI bench. And you can imagine if they already have flaws, these flaws get propagated to other benchmarks that are derivatives of these benchmarks. So we need to have like a process to refine these existing benchmarks. This is what we did. We and actually applied it to human eval and created human eval next. And this is the result. We tested it out on 10 models, and you can see that human eval plus, which is the next version of human eval, and our version, the performance has dropped for 30% on the new benchmark that we refined. The drop is also around 20% for Eval Plus, which already showcases that when you fix these issues and you make it stronger, you make it more difficult, you can also avoid the saturation problem in this way. And we also observed that some model families, such as CodeGEMA, they were least affected, but some, such as CodeQueen, they were most affected in this regard. The main takeaway from this work was that, of course, benchmarks, their quality is the key, and they shape the perception of the model progress. So if you like to find relevant benchmarks for your cases, feel free to use our tool, Bench Scout. And please do not rely on outdated benchmarks. It gives you a false sense of capability. And we need, as a community, we need to strive for continuous refinement of these benchmarks. The next one is HIP. It's called HIP. So these models need data for training, for evaluation. Hugging Face came up with this stack. It was a 3 terabyte of permissively licensed code back in 22, and then they came up with the version 2 of this data set, which everybody is using it in the open source community. But the data that is open source, if you want to evaluate on it, you're going to suffer from the data leakage problem. So the model has already seen it. And data contamination leads to misleading reports and estimated numbers. And only, to our surprise, only a few studies in the field actually really and concretely looked into the data contamination problem. So my students actually looked at it, and they came up with a clean version and contamination-free multilingual version of a dataset for fair evaluation, which is called the HIP. It contains 57 programming languages, and it only includes non-permissive copyleft license, which means that it shouldn't have been used for training these models, so you can safely use them for evaluating your models. And it consists of like more than 700,000 repositories, and it gives you the option of not running everything yourself and deduplicating your data sets for evaluation, etc. You can just take it. And our main goal was to increase the reproducibility and use this data because it contains non-permissive code only for research and evaluation, but it shouldn't be used for training models or like making profit out of it. The next benchmark we made was to look at another angle, going beyond the accuracy of this model and actually see the harmfulness in large language models for code. So why should we even worry about this? Because code can contain insecure, buggy contents. There could be backdoors in the code. And there also, when you are generating with these models, they can easily give you access to very harmful code. But the code models aren't aligned on helpfulness, honesty, and harmlessness. This is a framework often used in the natural language domain, but it's neglected for programming. And with this benchmark, we wanted to see how can we like assess these risks in the off-the-shelf large language models that are currently on the top of the list of performance. So we built this taxonomy of 3 main categories for malware, copyright, or unfair dangerous use. For example, imagine that you ask an LLM, give me the code to create a spyware. Give me the code to create a bomb or something. It should be aware of these dangerous cases, and it should avoid giving you harmful responses. So this is the case, this is the taxonomy that we created of harmful cases in coding, and we created 500 prompts around these categories of harmful cases, and with that we created the Hammurabi code dataset. Next, we also created an automatic evaluator to see whether the model is generating a harmful response. And we evaluated 70 language models here. Don't worry, you don't need to read this. You just need to know that the red is bad and the green is good. So meaning that the red is harmful responses by these models, and the good is, the green is the harmless responses. We also have cases, the orange one, that's warning. The model gives you a warning, but it also gives you the answer. And then the blue case is that it outright refuses to do anything, which is not helpful. So we see different angles: harmfulness, honesty, and harmlessness. And these categories indicate those. The main observation that we had here was that there is a wide disparity among these models, and in general, we could say that the larger the model was, the fewer harmful responses and more refusals. Certain code models, code families, show stronger harmlessness, such as Gemma and Llama from Google and Meta. But there were also cases of that they were even worse. This is called moralization alignment, which some of the fine-tuning policies, they try to avoid it because they believe that it's not the responsibility of the model builder to create something that's not harmful, but it's the responsibility of the user. So they actually reverse back any alignment that was done in the base model when they are fine-tuning them. And it had, as you can expect, naturally, it made them to generate more harmful responses than the base models themselves. The next observation was that the code-specific language models, they weren't safer than the generic ones. And finally, certain categories, they handle these cases differently. For example, for copyright code, like if you ask it to generate a copyrighted code for me, a specific type of it, it would avoid it and don't give you that answer. But for other types, such as malware and model attacks, it was more likely to give you the answer. I also wanted to briefly have a shout out to a competition my students are going to organize around these security aspects and the data contamination. This will be a competition next year at AIWare/FSC in Canada on devising techniques to understand membership inference from the models. And I think I'm over time, so I'm gonna skip. Maybe just a quick shout out to the Long Code Arena. This is a collaboration work we had with JetBrains. And the goal here was to showcase the abilities of models when consuming long code, not just like short function descriptions, etc., but a whole repository, a whole library, a whole module. And we included 6 different tasks. The benchmark is available on Hugging Face, and you can access it. And the main takeaway for today is that evaluations matter, and we need more independent evals as a community. They need to reflect practice better. We should avoid just offline and really like simplistic metrics. And finally, we should also be multidimensional. Fairness matters, safety, scalability, and the quality of the benchmarks and their maintainability are important aspects that we need to take into account as a community to be able to progress and showcase actual real progress with these models. And that's it. Thank you. I'm happy to take your questions.
Okay, 1 second. I'm involved in observability rather. In what is the overlap on a high level between observability and benchmark? These benchmarks you're running, you know, how's that going to play out? I mean, are these, you know, the observability players? They're just bogged down with the traditional metrics, traces, logs, et cetera. So, you know, what do the observability players? What should they be doing? Should they be adopting these types of benchmarking tools or not?
By observability, you mean the like telemetry data in the online evaluation?
Not just telemetry data, but processing, debugging, the whole process involved in observability, which range from monitoring to just inferences sometimes, debugging especially, and just having observability over your systems. So that's a traditional, you know, process. So how does that overlap with what you're doing?
So I'm not quite sure that I got the question right, okay. But I'm going to try.
Okay, when you open up your screen, you're looking at Grafana, right? You're looking at logs, metrics, traces, et cetera.
Yeah.
You're looking at your different systems. How's that going to play out in this space of benchmarking? Or can it?
So there are different type of evaluations, like the observability and like the online evaluation. You collect those telemetry data, but for benchmarking, it's kind of an offline evaluation that you have collected the data and you look over it. So there are cases for debugging in the landscape of benchmarking. There are cases for CI/CD, etc. And of course, they collect different type of data, which are also interconnected, and you need to like make sense of those as a user of those evals. And I gather that it's a bit more complex than like just code generation, etc. Yeah.
Okay. All right, thanks.
Yeah.
Any other questions? Okay.
Thank you so much for your lecture. We're actually talking a lot about benchmarking right now in the company I work for. I want to ask you, like, what the practical steps would be for implementing a benchmarking system within a company. So I'm not talking about benchmarking for code generating systems. That's a separate issue, but I'll give our example, and I'd be really interested to hear how you think about it.
Yeah.
We have a AI, I don't know what you want to call it, bot or agent that's connected to our data systems and can give our customers all sorts of insights. Now, we can benchmark the models that we're using behind the scenes, but we also want to be able to benchmark the use of our tools that we're generating within our company, our different agents that are interacting with one another. So what would be your approach to implementing an evaluation system within an independent project?
My first step would be to identify the targets, like what exactly the metrics that you want to measure. It could be like productivity, the time saved, like the accuracy of the results. I don't know, per your case, like what are those exact proxies? But when you are able to identify those proxies, then you can translate them to the metrics that you can measure them. For example, like take productivity. It's discussed all over the field, and everybody has a different meaning, like a different definition about it. And as a company, you need to define which proxy you are going to take as the metric. And then decide how to prioritize them, for example. If there is a golden metric for you, a golden aspect that you want to see through, or if it's a combination of those, then setting up the pipelines to actually collect those type of data. In many cases, you may be hurdled by like the privacy aspects. I don't know, like probably these are some of the challenges you will face. After setting up the pipeline of those, collecting those data, then you can have different, you can start collecting the benchmark. And I would suggest that you keep maintaining it to make sure of the quality remains top-notch. Yeah. And we can also... Yeah.
But you would generate an internal benchmark or use one of the systems that you described?
You can definitely use also off-the-shelf systems. There are many harnesses out there that you can use. There are many readily available benchmarks. And as a company, maybe that even makes more sense to use one of the existing ones to get a feel of the performance for your case. And after, if you identify like where are the challenges, then you can dig in deeper by collecting or making your own benchmark around it. But for sure, if it's just like the model itself, there are a ton of benchmarks out there that you can just try them out. But I would suggest that that would be only your first step, and then go to your own case. Yes.
Thank you.
Sure.